Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about one-step inequalities. We're going to solve each inequality, graph its solution. So if I was given this inequality, negative 12 is greater than x minus 7. So what I want to do here is first I'm going to simplify this to get x by itself, isolate it, treat it basically as if it's inequality with an equal sign. I'm going to add a 7 on both sides. And a negative 12 plus 7 is a negative 5. And so we're given that x is greater than negative 5, or we can think of it like this. Flip it around, x is less than negative 5. The open part is to the negative 5, the closed part of the inequality goes to the x, and there we go. We have x is less than negative 5. So how do I graph that? Well, let's go make a number line here. We want to make sure we have negative 5 in there. And there's different techniques. Some people always put, whatever number you're starting at right in the middle. So let's go with, let's go right here. Right, negative 5, negative 4, negative 3, negative 2, negative 1, 0, negative 6, negative 7, negative 8. Okay. Well, x right there, x is less than, meaning less than negative 5. At negative 5, we have an open circle. Right, we do an open circle there at negative 5. And then it says it's less than, so we're gonna write to the left, right? We'll make our bar go to the left. Now sometimes it's easier to see if you just do it above it, like that, to the left. But either way, there it is. It's one or the other. Don't do both of them. Okay. So that graph shows that x is less than all these values. That's less than negative 5. Negative 1 plus r is greater than or equal to 4. Okay. Well, first step, let's get r by itself. So I'm going to add a 1 both sides. That leaves me with r is greater than or equal to a positive 5. Pretty simple. R is already by itself. So r is greater than or equal to positive 5 is my final answer. But now I need to graph it. So let's make a graph here. Let's start with 5 here. We have 5, 6, 7, 8 on the number line. 4, 3, 2, 1. And there's good old 0. So we said r is greater than or equal to 5. So if r is greater than or equal to, we go to 5 and we're going to make a closed circle. All right, I'm going to draw this one above the number line. It can be on it or above it. I find it above sometimes a little easier to see. So right there at 5. And then it's greater than, so we're going to put our arrow to the right. And there we go. So we have r is greater than or equal to 5. It's graphed right here with a closed circle because of the equal to. And then it goes to the right, okay, because it's greater than. And minus 6 is less than or equal to negative 14. Okay? Well, first thing, I was going to bring the 6 over. So I'm going to add a 6 to both sides. Leave me with n by itself is less than or equal to, well, it's negative 14 plus 6. And we're looking at a negative 8 there. Okay? So we have n is less than or equal to negative 8. Fantastic. We got a nice little answer there. So now we need to graph it. So let's put a negative 8 here. And this one we go by 2's. So negative 6, negative 4, negative 2, here's 0. We got 10, 12, 14, and 16. Why not? So we said n is less than or equal to negative 8. So at negative 8, I'm going to put a closed circle. A closed circle at negative 8. And we need to shade to the left of it because it's less than. So my arrow is going to go to the left. And there we go. We have our graph that matches our inequality, which both are our final answer. B minus 7 is less than a negative 12. So b minus 7 is less than negative 12. I'm going to add a 7 to both sides. And, oh my goodness. And what that gives me, add a 7 to both sides. That gives me b is less than negative 12 plus 7, which is a negative 5. Okay? So now I need to graph that. We have b by itself with our inequality. So if I graph this, I'm going to have a negative 5 here. We have a negative 4, negative 3, negative 2, negative 1, 0, negative 6, negative 7, trouble 7 today, negative 8, negative 9. So b is less than negative 5, put an open circle. So an open circle there, less than a negative 5, and I'm going to shade it to the left. So I'm going to draw my arrow to the left here, and there we are. But if b is less than negative 5, we have an open circle at negative 5, and the arrow went to the left. A minus 17 is greater than negative 16. Okay? Well, first thing, I need to add the 17 to both sides. If I add the 17 to both sides, I'm left with a by itself is greater than negative 16 plus 17 is a positive 1. So a is isolated. We're good. So now I need to graph that. All right. So if I'm graphing this, I start with a is greater than a 1, right? Greater than. So I'm going to open circle at the 1, okay? And then greater than means I'm going to move my arrow to the right, whatever is greater than 1. And there we are. So we have a graph now that matches, that shows our a is greater than 1. Plus x is less than or equal to 0. Well, my first step is I need to get the x by itself. So I'm going to subtract a 15 to both sides. That leaves me with an x is less than 0 minus 15, which is a negative 15. Okay? So I need to have my number line now because x is already isolated, and that's my final answer. X is less than or equal to negative 15. So we make a number line here. Well, let's do this. Negative 15, negative 10, negative 5, 0, negative 20. What I love about graphing these is I have the freedom to really make my number line what I want it to be, right? Make sure it's even. Each tick mark, has the same unit space in between. Let's put negative 25 here. Why not? And so now I can graph this. Well, negative 15 is what I'm looking for. It's less than or equal to, so I have a closed circle. A little closed circle here. Closed circle at negative 15. Then from there, I need a shade to the left because it's less than. So it's less than or equal to right there. So this is the less than part. The closed circle is equal to the negative 15. And that matches our answer, which is x is less than negative 15. b plus b is less than or equal to a negative 9. Well, my first step here is I need to subtract a 3 to both sides. So I'm going to subtract a 3 to both sides, leaving me with b is less than or equal to negative 9 minus 3, which is a negative 12. So v is less than or equal to a negative 12 here, and that is my final answer. But I need to graph it. So let's make a graph here. Let's put a negative 12. And let's go by 2. So we have negative 10, negative 8, negative 6, and somewhere over here is going to be 0, but I don't need that far. We have negative 14, negative 16, negative 18, and negative 20. Okay, so v is less than or equal to a negative 12. The equal to sign gives me a closed circle right there. And the less than sign puts the arrow to the left. And there we have it. We have a graph here that matches our inequality of v is less than or equal to negative 12. 8 is greater than or equal to n minus 6. Okay. My first step is to get the 6 over to the left. So I'm going to add a 6 to both sides. Let's isolate that n. 8 plus 6 is 14. So 14 is greater than or equal to n. Let's rewrite this, have n come first. N is less than or equal to 14. The way I always remember to do that, when you flip it, you have to flip the inequality as well, and make sure the pointy part is towards the n and the open part is towards the number. All right, keep the equal to sign. So they're the same thing, but written at first. N is less than or equal to 14. Let's grab our number line here. Let's go 14 right there. Why not? And let's go 16, 18, I like going by 2 sometimes, 20, 12, not 20, 12, but 10 and 8, okay, by 2's. So n is less than or equal to 14. We're going to put, since it's equal to a closed circle at 14. and we're going to draw to the left, because it's less than, the arrow. And there we have it. We have our graph that matches our inequality of n is less than or equal to 14. Negative 3x is greater than 3. Well, first thing I need to do is get x by itself. So I'm going to divide by negative 3 to both sides. My x is by itself on the left, but when I divide by negative over the inequality, I need to flip the inequality. Okay? Remember, I'm flipping that inequality. So from greater than, it turns into a less than. Then 3 divided by negative 3 is a negative 1. And now I have my final answer of x is less than a negative 1. But now I need to graph that. Okay? So we graph that. We have a negative 1 here. There's 0, positive 1, 2, 3, and negative 2, negative 3, and negative 4. Okay? So if x is less than a negative 1, we have the open circle at our negative 1. And since it's less than, we put the arrow to the left right there. So we have x is less than a negative 1, open circle at negative 1. Arrow goes to the left right there. And there we have it. That matches up with our answer of x is less than negative 1. N over 3 is greater than 3. Well, my first step is to get n by itself. So I'm going to multiply both sides by a positive 3. What that does is it eliminates the 3 on the left, giving me n by itself. N is greater than 3 times 3, which is 9. So we have n is greater than 9. N by itself is isolated. Fantastic. That's great. So we have n is greater than 9 right there. But now I need to rewrite this, make a graph that matches this, right? So we make a graph here. Start with 9. We have 9. Let's go by 2s. 11, 13, 14. It's not by 2, Sean. 15. Go with the odds. 17. And then we have 7, 5, and 3. Okay? So if I want to graph n is greater than 9 here, greater than 9, I have an open circle, because it's not equal to, open circle at 9. And the greater than sign puts the arrow to the right. So we have greater than 9, open circle, greater than 9, arrow to the right, and there we are. That graph matches the inequality of n is greater than 9. K over 4 is less than a negative 4. Well, to get k by itself, I've multiplied by 4 to both sides. That eliminates the 4 on the left, giving me k on the left is less than negative 4 times 4, which is a negative 16. So if k is less than a negative 16, and there we are. K is by itself, looking great. So now I need to use my number line, match it up. Okay? So let's put a negative 16 here, and let's go by 4s. Let's change it up. Negative 12 is right there. Negative 8, negative 4, 0, negative 20, negative 24, negative 28. So x is less than a negative 16, so just as less than, I have an open circle, because it's not the equal to, and it's going to the left because it's less than, so I draw my arrow to the left, and there we have it, where our graph here represents k is less than, but not equal to, less than, negative 16, shading to the left. Negative 9x is greater than or equal to negative 90. Okay? Well, first thing I'm going to do here is get x by itself. So I'm going to divide by negative 9 to both sides. By doing that, I'm left with the x. And then on the right, negative 90 divided by negative 9 is a positive 10. But since I divided by a negative over inequality, I need to flip the inequality. So my greater than or equal to sign turns into a less than or equal to sign. So now x is isolated here. I have x is less than or equal to a positive 10. I need to graph that. So kind of short graph, but it's okay. 10, 12, 14, let's go by 2s, 16, 8, 6, 4. Okay, so x is less than or equal to 10. At 10, I have a closed circle. And since it's less than, I'm going to draw my arrow to the left from there. And so if x is less than or equal to a positive 10, and there we go. We have our graph here that matches our inequality. Okay. 0 is greater than or equal to 7n. So I want to get n by itself. So I need to divide by 7 to both sides. And that leaves me, well, 0 divided by 7 is 0. So 0 is greater than or equal to n. Well, if I rewrite this, have n come first, or at the end over there, the pointy side is still close to the n, and it's still equal to, and the 0 is open by the open mouth. So my greater than sign turns into a less than sign. Okay, I flip the sign when you do that. And so if I want to make this into a graph now, right, I'm going to graph it with 0 right in the middle. 1, 2, 3, 4, -1, -2, -3, and -4. Well, if I'm n can equal 0, so that means I'm going to put a closed circle right there. Then n is less than also 0, so I'm going to make my arrow to the left, and now we have a graph here that represents all the values that n can be. They can be 0 as well as everything to the left. That's negative, right? Less than 0. M over 5 is greater than or equal to a -5. Well, my first step here is I need to isolate n. So I'm going to multiply both sides by 5. What that does is leave me m by itself and says it's greater than or equal to, well, 5 times -5, or -5 times 5 is a -25. So what that tells us here is that m is already isolated, is greater than or equal to -25. So if I want to make a graph out of this, okay, I'm going to put -25 here. Let's go by 5s. -20, -15, -10, -5, 0. Then we have a -30 here and a -35. Well, what they told me is that m can equal -25. So I'm going to put a closed circle right there at -25. Then m is greater than that. Okay? So if m is greater than that as well, we need to make our arrow go to the right, to the greater than side, right? Because in reality, think about this, -10 is greater than -25. Okay, that's a good little check there. Okay? So this graph represents, represents our answer here, which is m is greater than or equal to a -25. -13x is less than a -156. Well, my first step is I need to divide by a -13. By dividing by a -13, I eliminate the -13 on the left, giving me x by itself. And on the right, well, I need to figure out how many times is 13 going to 156. Now we have a negative divided by a negative, which is a positive, right? So we know our answer is going to be positive. So I have 13 going into 156 here. 13 goes in 15 one time. 1 times 13 is 13. Subtract them. 15 minus 13 is 2. Bring down the 6 here. 13 goes into 26 2 times evenly. 2 times 13 is 26. And great, we're good. So we got 12. So 12, 156 divided by 13 is a 12, and it's a positive 12. But now my inequality. My inequality needs to flip because I divided over the inequality by a negative. So right there, I take my less than sign and I convert it and make it into a greater than sign. And so now my final answer is x is greater than 12. So now I need to graph that. So make a little number line here. We have 12, and let's go by 2s, 14, 16, 18, and 20. And we have 8, and 6, and 4. Well, if x has to be greater than 12, right, it's greater than, not equal to, it doesn't equal 12, we're going to have an open circle. So an open circle right there, and since x is greater than, I'm going to shade to the right, okay? Because those values to the right are what values x can be, right? 14, true statement, let's see, 14, is 14 greater than 12? Yes, it is. 16? Yes, it is. All those values here are greater than 12, and so this graph here represents our inequality. X is greater than 12. 32 is greater than or equal to a -16p. Okay? So what I'm actually going to do first here is I'm going to rearrange this. All right? I'm going to put my -16p first, and then 32 on this side, and I have to flip the inequality doing that. And we're going to do actually a lot of flipping of the inequality in this problem here. What that does is, from the beginning, on this problem, I decided to put p out on the left first because I know I want that in general. Then, from there, I'm going to divide by -16 to both sides. What that does leaves me with a p by itself on the left, and 32 divided by -16 is a -2 on the right, but then I have to flip the inequality again. So we have to be careful. We have a double flip going on here. So we have p is greater than or equal to a -2, and that is our answer. But I need to graph it. So, make a number line here. Let's go at 0, -1, -2, -3, -4, and 1, 2, 3, and 4. Okay? Well, they told us that p can be equal to -2, so I'm going to put a closed circle right there at -2. Then it's also greater than -2, so my line needs to go to the right. Now my graph matches my inequality of p is greater than or equal to -2. -8 is greater than v minus 3. Well, my first step is I need to add a 3 to both sides. That leaves me with -8 plus 3 to be a -5. That's greater than v. And so I want to rewrite that, though. Even though v is already isolated, I want to have v come first, because that looks nice and neat. So I have the v come first. I have the -5 over here, so I'm flipping them. And if I'm flipping it, I need to flip the inequality as well. That leaves me, instead of -5 is greater than v, I have v is less than -5, which both are really the same answer, or same statement. And so we have our final answer here of v is less than -5. And so now I need to graph that. So we have, let's go -5 here. We have 0. Let's go by 5s. 5. We have -10 and -15. Well, v is less than -5. It's not equal to. I'm going to put an open circle here at -5. Then we said v was less than 5. So I draw my line to the left from that open circle, indicating that all these values less than -5 are values that v can be. Okay, so my graph matches up with my inequality of v is less than -5. 11 is greater than or equal to 5 plus x. Okay? Well, I need to get x by itself, so I'm going to subtract a 5 to both sides. And in doing so, by subtracting 5 to both sides, I'm left with x on the right and 11 minus 5 on the left, which is 6. But I need to have, even though x is isolated, I want to have x written first. So I'm going to rewrite this, have x is first and 6 on this side, and make sure when I do that, I also have to flip the inequality. So I have less or greater than now or equal to. So when 6 is less than or equal to x, it's the same thing as x is greater than or equal to 6. And that is my final answer. But I need to graph it. So by graphing it right here, okay, I need to show that x is greater than or equal to 6. So let's go put 6 here. We have 7, 8, 9, and 10. And 5, 4, 3, and 2. Okay? So if x is greater than or equal to 6, all right, I need a closed circle at 6 because it's going to equal 6. Then we said x is greater than 6. So my arrow is going to go to the right, showing that x can be any of these values that are greater than 6, like 8, right? 8 fits, right? If I put 8 into this inequality, it makes it a true statement, right? So it does not. So does 6, right? 6 is greater than or equal to 6. But 5 does not, right? 5 goes in. 5, not greater than or equal to 6. That's not true, and it doesn't match with my graph. So my graph does match my inequality, which is x is greater than or equal to 6. 25 is greater than or equal to n plus 13. Okay? Well, my first step is I need to isolate the n. So I'm going to subtract a 13 to both sides. That leaves me with 25 minus 13 on the left, which comes out to be 12, right? It's greater than or equal to n, which is just left to the right. Now I'm going to rewrite this to have n come first, because that looks nice and neat. So we have n here. We need to flip the inequality when we do that. So now instead of greater than or equal to, it's less than or equal to. And the 12 now is on the right. Okay? I like to think about it as the pointy side stays with the n, and the open side stays with the 12. Okay? Anyway, I have a final answer though. It's by itself, it's isolated, looks nice and neat. N is first. So if n is less than or equal to 12. Now I need to graph that. So make a little number line here. Let's put 12 right there. Let's go by 2s, 14, right? And we have 10 and 8 and 6 and 4 and 2 and 0 and -2 over here. And it keeps going forever and ever. Okay? Yeah, I got all of them. Go by 2s. Well, since n can equal a 12, right, we're going to have a closed circle right here over 12. All right? It can equal the 12. Then n is also less than that 12. So I want to put a line that goes to the left. All the values that are less than 12. Okay? So now I have a graph. That graph matches my inequality, which is n is less than or equal to 12. Negative 168 is greater than a negative 12a. Well, my first step is I need to get a by itself, isolate it. So I'm going to divide both sides by negative 12. In doing that, I'm left with a on the right, and on the left-hand side, I have to figure out how many times is 12 going to 168. So let's do some long division, 12 into 168. And we know a negative divided by negative is a positive, so it's going to be a positive answer. 12 goes into 16 one time. 1 times 12 is 12. Subtract them, bring down to 4. Or 16 minus 12 is 4, bring down to 8. 12 goes into 48 4 times. 4 times 12 is 48. We subtract them, we get 0. Fantastic, so we have a 14 here on the left. But I divided by a negative over the inequality. What that does is it flips the inequality from greater than to a less than sign. So now we have 14 is less than a. I want to rewrite this that a comes first. So a comes first. By doing that, I flip the inequality. So a is now greater than 14 here on the right. And that's it. So a is isolated by itself. So we kind of had a double flip the inequality with our steps. So we have a is greater than 14. So now I need to graph that. Well, make a little number line here. Pretty quick and easy. Okay, let's go put 14 here. Let's go by 2's. So we have 16 and 18 and 20 and 22. And we'll put a 12 right here and a good old 10. Okay. So well, since a is greater than 14, it doesn't equal 14, but 14 is my starting point. Since it's not equal to 14, I'm going to put an open circle at 14. Then, since a is greater than 14, I'm drawing my line to the right. All right, all the values that are greater than 14. Now I have a graph that matches the inequality. All right, and so we're basically done now. That's our final answer. This graph here shows that a is greater than 14. Negative 3 is less than or equal to x minus 4. Okay? Well, my first step is to bring the 4 over to get x by itself. So I'm going to add a 4 to both sides. What that does now is negative 3 plus 4 is a positive 1, and that's less than or equal to x. Okay? But I want to write x first. So by doing that, by writing x first, I then have to flip the inequality back, go from less than or equal to be a greater than or equal to, and to that 1. So 1 is less than or equal to x is the same thing as x is greater than or equal to 1, which is my final answer. So now I need to graph it. Okay, so make it a little number line. 0, 1, 2, 3, 4, 5. And we have negative 1, negative 2, negative 3, and negative 4. And make it even, negative 5. Since x is greater than or equal to, the equal to is the key part here, which shows it's a closed circle at 1. Then x is greater than, so we're going to shade to the right. By shading to the right, we're representing the greater than part, and the closed circle represents the equal to part of 1. So this graph now matches our inequality, which is x is greater than or equal to 1. R over 3 is greater than 6. My first step to isolate r is to multiply both sides by 3. And in doing that, I'm left with r by itself on the left here, because these 3's will cancel, and 6 times 3 is a positive 18. So that's almost right, 16, 18. So we have a positive 18 right there. So now r is isolated, so r is greater than 18. So now I need to graph it. So let's make a little graph here. Let's put 18 right there. And let's go by 2. So we have 20, 22, 24, and 26. Let's go less than 16, 14, and 12. Okay? So now r is greater than 18. It's not equal to. Since it's not equal to, we have an open circle there, 18. Then, since r is greater than, I need to shade to the right, to the values that are greater than. And now we're good. We have all the values here in our graph that represent where r is greater than 18, right? 26 is one of them. Is 26 greater than 18? If I plug it in? True. True statement. 14? Not so much, right? If I plug 14 in, 14 is not greater than 18. What about 18? If I plug 18 in for r, is 18 greater than 18? Well, no. 18 is equal to 18, right? So that's why we have the open circle showing that it doesn't equal 18. So this graph represents my final answer, which is r is greater than 18. 12n is greater than or equal to 84, okay? Well, I first need to isolate n, right? It was multiplication, 12 times n. So now I'm going to divide by 12 to both sides. That leaves me an n by itself on the left, which is what I wanted, is greater than or equal to, well, what's 84 divided by 12? And that comes out to be 7, okay? So 84 divided by 12 is 7, because 7 times 12 is 84. And now n is isolated, it's greater than or equal to 7, and we have our final answer. So now I need to graph it, okay? So I take make a number line here, and I'll put 7 right there. Why not? And go by 1s, 8, 9, 10, 11. I have some freedoms here with it. 6, 5, and 4. Okay? So now I need to graph this. Well, since n can equal 7, I need a closed circle at 7. Okay? Then n is greater than 7, right? Also, I make my arrow to the right. Okay? All the values where n is greater than 7. Okay? So now I have n is greater than equal to 7 represented in the graph, and it matches my final answer, which was n was greater than equal to 7, right? And this graph represents all values that n can be, okay? Negative 22 is greater than a negative 10 plus b, okay? Well, my first step here is I need to add a 10 to both sides to get b by itself. So I'm adding a 10 to both sides, and the negative 22 plus 10 is a negative 12, and that's greater than b. Now I want to write b first, though. So by writing b first, I need to flip the inequality as well. So instead of greater than sign, I have a less than sign. So negative 12 is greater than b. It's the same thing as b is less than a negative 12. Now I have b written first, which is fantastic. And so it's isolated, so we're done, right? b is less than negative 12 is my final answer. But now I need to graph it. So I'm going to graph it here. I'm going to put negative 12 down. So let's go put negative 12 right here. And we have negative 10 to the right, negative 8, and negative 6. And we have, go by 2's here, negative 14, and negative 16, and negative 18. Okay? Well, b is less than negative 12. Because it's just the less than sign, and it's not equal to negative 12, we have an open circle at negative 12. Then from there, we see b is less than negative 12. So I'm going to put my arrow to the left of negative 12. And so now I have a graph here that represents all possible b values, right? All values where b is less than negative 12, which is that final answer.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.